In this video, we're going to look at some of the more complicated examples for what can happen when you're using the law of sines. So in the last video, we talked about the situations where they may give you two angles and one side. Now we're looking at problems where they give you two sides and one angle. So most of the complications we have occur when you are having to solve for an angle in the triangle instead of one of the sides. And we have a couple possible outcomes here. The first possibility is when you are doing your solution and you go through your cross-multiplying process, you may end up with a statement that says sine of x equals a number, and if that number is bigger than 1, so say your cross-multiplication leads to something like sine of x equals 1.7. If that number is bigger than 1, then no triangle can be made out of the given information. Basically, the sides that they gave you, they just don't work. Maybe one of the sides is too long or something for you to create a triangle out of it. The more common example, what we call the ambiguous case, is when you solve for that missing angle and you go through the law of sines process. Once you set up your cross multiplication and get an answer for the angle, like let's say you get in your calculator an answer of 40 degrees, when you find an angle using law of sines, then you also have to take that number your calculator says and subtract that number from 180 to get a second possible answer. So if your calculator from solving the problem says 40 degrees is the answer, you also have to do 180 minus 40, which is 140. And so that'll create two different possible answers for the angle that you were looking for, and we'll have to solve each of those triangles separately. So sometimes there will be two triangles, and you'll have to get all three sides and angles for both of them. Sometimes that second possible number, the 140 degrees I was talking about, you'll take that second possible angle and then add it to the original angle you were given in the problem. Because remember, you should have been given one angle for this situation to happen. So if you take the original angle and the angle you found by subtracting the one in the calculator from 180, those numbers might be too big. So if we got 140 in our calculator, but the number we were given originally was 50, those two numbers add up to 190. So we can't find a third angle in the triangle to make that one work. That way we can just ignore that whole second set of solutions. But if the angle we got from subtracting from 180 was 140, and then the angle in the original problem was something like 20, then those two only add up to 160, which means we can find a third angle in the triangle. We can find a third number to add together to make it equal to 180. So this is the most confusing part usually on the unit. Just keep in mind that whenever you are solving for an angle, don't forget to subtract the number from 180, and then just split it up into a second triangle and see if the numbers can be used to possibly create a triangle. See if you can get angles that will add up to 180 doing that. Here's our first example. We've been given two sides and one angle. So I plugged the values into the law of sines. I have sine of 61 over 8 equals sine of b over 21. And then the value I'm missing, what I'm going to be solving for, is this capital letter B here. So since this is a capital letter, since this is one of the angles that I'm solving for, I do have to consider the complications that just showed you on the last slide. So my next step is going to be to cross multiply and write 21 sine of 61 and 8 times sine of b. Now we're trying to solve for sine of b. So since I have 8 times sine of b, my next step will be dividing both sides by 8. Now I can just take this number and plug it into my calculator to see what sine of b is equal to. Now since this number isn't just what the capital B equals, this isn't just what the angle B is, this is what sine of b equals, usually your next step would be to take the sine inverse of both sides of the equation. And then that would cancel out the sine, the inverse and the regular function cancel. So we would have angle B equals, and then we would put into the calculator sine inverse of this number. But stop for a second and notice that this number is 2.295877. This is the first situation I was referring to here on this top bullet, where I said we got a solution of sine of x equal to a number, and that number is bigger than 1. Since the number was 2 point something, it's bigger than 1, and that means no triangle could be made out of this given information. So in any answer, we would just say there is no triangle or there is no solution because we can't get angles and sides that will turn these values into a triangle. So depending on what your answers are, you would just be indicating something that says this is not a triangle or there is no solution to the problem. Now as a tip, I like to actually start each example where I see that I have two sides and one angle, so I know I'm solving for an angle. I like to start all the problems off like that by listing out my angle A, side A, angle B, side B, angle C, side C for triangle 1. That's why I've used this little subscript of 1 on all the values. And I like to consider that I know there's a possibility of there being a second triangle, and I want to be able to tell the difference between angle A in the first triangle and angle A in the side triangle. So whenever I see that I'm solving for an angle using law of sines, I always like to start off by just listing all of my values out here. My next step will be to actually start considering what the values are going to be. Now, the numbers that they give you in the original problem, those will be true in both triangles. So we can actually fill in the angle A for both triangles, the side A for both triangles, and the side B for both triangles. So starting off my law of sines, I know that I would have sine of 26.3 over 7 equals sine of B, because I don't know that angle yet, over 6. Next, we would just go through the cross multiplying process and solve for the sine of B value. So what you should have been putting into your calculator is 6 times sine of 26.3 and then divided it by 7. That should give you this value I have here, the 0.3798. Now I kind of rounded it off there for what I wrote, but you actually don't want to do any rounding while you're working through the problem. You want to make use of a key in your calculator that says ANS, and it lets you keep inputting the previous answer. So don't just round off after a certain number of decimal places, keep trying to enter the entire number by using that ANS key in your calculator. So once you get to this point, we had sine of B equals this ugly number, but that's not what angle B is, so your next step to get rid of the sine is to take sine inverse of both sides of the equation. So sine inverse of that decimal going past the 0.3798, so taking sine inverse of that number gives me an angle of 22.3. Once you get to your answer for this angular side, that's when you can round it to the nearest tenth. But please do not round anything until you get to the answer for a side or angle value. And that's the angle B for the first triangle only. So we should be indicating that this is just B1. So now I want to point out our instructions again. We just found a missing angle using the law of sines, so I need to pay attention to the second bullet. What we have to do next is subtract that angle we found from 180 degrees to get a second possible angle for angle B. So the angle we found was 22.3. That means I need to do 180 minus 22.3, and that gave me 157.7. So the answer from the calculator was angle B for the first triangle. The answer we got by subtracting that number from 180 is angle B for the second triangle. So we have two different angle B's, and this is where our triangle potentially splits into two different sets of answers. So next we'll want to see if it is possible to build a triangle out of this second set of values. Now we're going to look at this third bullet. So the second possible angle we got by doing the angle B minus subtracted from 180, we need to take that number and the angle that was given to us in the original problem. If those two angles add up to something bigger than 180 degrees, then it won't be possible to make a second triangle out of those values. So we won't have to worry about the stuff I've written in red so far. So let's look back at our original angle and the angle we just found. Well, if we take the original angle from the problem, 26.3, and add the new angle we were just considering, 157.7, those two numbers add up to 184. So we wouldn't be able to do 180 minus this number to find the third possible angle in the triangle. So what has just happened here is we've created a situation where there is only one triangle. We basically get to ignore all of this stuff. These values do not make a triangle because the angle we got and the angle we were given are too big to make a triangle, which means now we would only have to finish solving the first triangle. And I'm not going to write the rest of that out since that would go back to what we did in the previous video. But basically, we have two of the angles for the triangle. So we would subtract them from 180 to get this value. And then we would use law of sines again to solve for the missing side. Remember, solving for the sides is a lot easier for law of sines because you don't have all of this complicated stuff that causes it to split. So 180 minus the two angles to get this value, and then use law of sines to find this value, and you would be done. So now for one last example, we'll consider the case that does have two triangles. Again, I see in the problem that we were given two sides and one angle. So when we set up our law of sines to solve for this, I see that it's an angle we're solving for, which means we do have to consider our ambiguous case. So I've gone ahead and I've written out two sets of triangle values, the angles and sides for triangle 1 and the angles and sides for triangle 2. Don't forget that the values given to us in the original problem get used for both triangles either way. So I went ahead and wrote that angle A is 30, side A is 6, and side B is 7 for both triangles. Now we just need to solve this law of sines setup. So go ahead and compute in your calculator 7 times sine of 30, and that'll equal 6 times sine of B. So then divide that number by 6. You should have gotten 0.5833 to equal sine of B, but don't forget that that's sine of B, not just B. So then you need to take sine inverse of that number in your calculator. So hit sine inverse of the previous answer using that A and S key. So I got 35.7 degrees for angle B. Now remember, this is just angle B in the first triangle, so it's always good to use the subscripts and not lose track of which value you're solving for here. So 35.7 is the angle B for the first triangle. To find angle B for the second triangle, we need to do 180 minus that number. So subtracting that number from 180 gave me 144.3 degrees. So that would be my second version of angle B, my second possible value for it. To see if I can make a triangle out of this, we want to do 30 plus 144.3, and you should get 174.3 out of that. Since those two numbers are not bigger than 180, then we can find the third angle of the triangle by doing 180 minus the two numbers we know, and that will give us a third angle for the triangle of 5.7 degrees. So this time it was possible to find a third value. And again, what I did to determine that was I took these two angles and added them up. Since it was a number less than 180, I was able to subtract it from 180 to find the third angle in the triangle. You would do the same thing to find angle C in the first triangle. You would do 180 minus the two angles you know. Don't forget that rule from geometry. Whenever you know two angles, just subtract them from 180 to find the third. So at this point, what you really want to do is kind of consider them as two completely separate problems. So just look at the values in blue. You would want to use law of sines again to solve for this missing side, and then use law of sines on the triangle with the numbers in red to solve for this missing side. So I'm going to write those computations out, but we'll go through it kind of quickly since everything else from here is stuff we've already talked about. So to finish off the first triangle, I always like going back to the values I was given in the original problem rather than ones that I found on my own through my work, because then I know that there's some rounding on these numbers, so they might not be as precise. So I always recommend going back to the original values from the original problem. So I did sine of 30 over 6, and I set it equal to sine of 114.3 over c, and I cross multiplied. So 6 times sine of 114.3, and then divide that number by sine of 30. So I got an answer of 10.9 on this one. We did not have to use sine inverse because this was equal to c, not sine of c. So that's the difference on when you use the inverse trig function. Now we'll do the same thing to solve for the side c in the red triangle. So for this triangle, you have sine of 30 over 6 equals sine of 5.7 over c2. We would do 6 times sine of 5.7 and then divide it by the sine of 30, and I got a value of 1.2. So we have two completely different sets of answers for two different triangles. If they refer to something as the acute angle or the obtuse angle, the acute one means a small one less than 90 degrees, and an obtuse one means a large angle bigger than 90 degrees. So basically, if they're talking about the two triangles, usually they're referring to the angle that you found. So we found angle B. This would be the acute triangle then, and this would be the obtuse triangle because this one has an angle B bigger than 90, and this one has an angle B less than 90. So that's it for the notes on the ambiguous case of law of sines. Thank you.